Hello everyone, this is Sravanthi, working as Assistant Professor, Department of Chemistry in Institute of Aeronautical Engineering. Today we are going to discuss about definition and terminology of polymer technology. So define polymer. So polymer can be defined as the large molecules, means macromolecules formed by the linkage of small molecules called monomer. So poly, from the Greek, poly means many, mer means parts. So many parts combined to give polymer. So from the Greek, poly means many, mer means parts. So many parts combined to give polymer. So it is a large molecular weight compound. That means number of monomer single units combined to give polymer. So polymer is a high molecular weight compound. Define homopolymer. So when the same kind of monomers joins, the polymer is called homopolymer. That means here generally monomers undergoes polymerization then form polymer. So here linking monomers all are same monomeric units repeated in polymer, that is called homopolymer. For example, ethylene, polyethylene. This is the ethylene monomer. So number of ethylene monomer repeated, so then form polyethylene. This is a polymer. So same monomer repeated several times then form polymer. The type of polymers are called homopolymers. Define copolymer. So when the different kind of monomers join, two different monomers are combined to form copolymer. Two different monomers, for example, butadiene. So here butadiene and styrene, two different monomers combined to form copolymer. And next, what is addition polymerization? So here addition of monomers without eliminating any byproduct. Generally polymer undergoes, that means monomer undergoes to form polymer. That process is called polymerization. So there are two types of polymerizations are there. One is addition polymerization and another one is condensation polymerization. So addition polymerization means addition of monomers without eliminating any byproduct. Without eliminating any byproduct or elimination of simple molecules. Mostly without eliminating any byproduct. The type of polymerization is called addition polymerization. So only addition of monomers without eliminating any byproduct. So is called addition polymerization. Best example is same polyethylene. So here ethylene monomer undergoes addition polymerization then form polyethylene. That means same monomeric unit several times with here only adding without eliminating any byproduct. So best example of addition polymerization is polyethylene, polyvinyl chloride and polystyrene. Next, what is polymerization? So just now we discussed already, monomer undergoes polymerization then form polymer, or number of monomers combined to give polymer. So it is a high molecular weight compound. So the process is called polymerization. So here a polymer is a large single chain like molecule in which repeating units derived from the small molecules is called monomers are bound together. So the process by which monomers are transferred into polymer is called polymerization. So simply we say that monomer convert to polymer. That process is called polymerization. Or otherwise low molecular weight compound converted into high molecular weight compound. This process is called polymerization. So what is condensation polymerization? So condensation polymers are those in which two or unlike monomers joined together by the elimination of small molecules such as water, HCl, etc. So simply we say condensation polymerization means it is formed by the two different functional group of monomers. Two different functional group of monomers. And in this case, eliminating byproduct. Elimination of byproduct like water molecule or HCl, etc. So, this type of polymers are formed by the two different functional group of monomers and eliminating byproduct. This process is called condensation polymerization. Best example is nylon 66 and terylene, etc. So, these are formed by this condensation polymerization. Next, what is copolymerization? So, when the different kind of monomers join, two different types of monomers join, the polymer is called copolymer. This process is called copolymerization. So, you see, generally polymerization means low molecular weight compound converted into high molecular weight compound. That means monomer into polymer. So, this process is called polymerization. So, there are three types of polymerization as there: addition, condensation and copolymerization. What is the difference between these three types of polymerization? In addition polymerization, only addition of monomers without eliminating any byproduct. Best example is polyethylene and polyvinyl chloride, etc. So here, next, condensation polymerization. These polymers are formed by the functional group of monomers and eliminating byproduct. So, best example is nylon 66 and terylene. And third type of polymerization is copolymerization. So, here two different kind of monomers combine to form polymer. This type of polymerization is called copolymerization. Best example is bunias and butyl rubber. So, these are formed by the two different kind of monomers to give copolymers. And next, what is resin? So, here the product of polymerization is called resins. And this forms the major portion of the body of plastics. So, it is the binder which holds the different constituents together. So, here mainly resin is used for binding purpose. So, it acts as a binder. It plays an important role in the compounding of plastics or preparation of plastics. That means it binds all the constituents which are used for the preparation of plastics. So, it acts as a binder. Next, what is plastic? So, it is formed in a desired shape by the effect of mechanical force and heat. So, simply we say plastic means, from the Greek, plastic means moldable. So, from the Greek, plastic means moldable. So, the polymer which can be molded into hard, tough, utility article by the application of heat and pressure is called plastic. So, from the Greek, plastic means moldable. So, the polymer which can be molded into hard, tough, utility article by the application of heat and pressure is called plastic. Or otherwise, it is formed in a desired shape by the effect of mechanical force and heat. It is also called as plastic. But plastic means moldable. And next one is, what are thermoplastic resins? What are thermoplastic resins? So, these resins are made of long chains attached by the weak van der Waals force of attraction. So, here thermoplastic resins, generally this type of polymers are formed by the addition polymerization. The definition of thermoplastics is soft on heating, hard on cooling. Soft on heating, hard on cooling is called thermoplastics. So, generally these are formed by the weak van der Waals forces and addition polymerization process. The best example of thermoplastic resins are polyethylene, polyvinyl chloride and polystyrene, etc. So, soft on heating, hard on cooling is called thermoplastics. So, these are formed by these are the made of long chain attached by weak van der Waals forces of attraction is called thermoplastic resins. The next one is, what is thermosetting plastics? Thermosetting plastics. So these resins have three-dimensional network. These resins have three-dimensional network structure, connected bonds. That means here only hard on heating. So once we converted this material, hard material, we cannot soften again. We cannot reuse it. The type of plastics are called thermosetting plastics or thermosetting resins. And these are formed by, this type of polymers are formed by the condensation polymerization. And these bonds are linked strong covalent bonds. So the type of resins are called, plastics are called thermosetting plastics. Hard on heating. We cannot reuse it again once it converts to hard material. But thermoplastics, we can remold it. That means we are using number of cycles on heating process because it is soft on heating. So okay, we can remold it, this thermoplastics. So a thermosetting plastics best example is bakelite, for phenol formaldehyde resin, bakelite or phenol formaldehyde resin. Next one is, what is chain polymerization? Give examples. So what is chain polymerization? The monomer units join together to form a large chain is known as chain polymerization. So simply we say it is also called as addition polymerization. So number of monomer units joined together. So in this case, number of monomer units combined to form polymer. So already we know that monomer is a low molecular weight compound and polymer is a high molecular weight compound. So a monomer units joined together to form a large chain is known as chain polymerization. And next question is, what is step growth polymerization and give examples? So in step growth polymerization, it is also called as condensation polymerization. So here in the step growth polymerization, the polymers are formed by the independent reaction between functional group of the simple monomer units. So just now we discussed already what is condensation polymerization. It is formed by the functional group of monomers. So here in the step growth polymerization, it is also called as condensation polymerization. Here this type of polymers are formed by the functional group of monomers and eliminating byproduct. So this type of polymerization is called step growth polymerization. Best example is nylon 6,6, terylene, bakelite. So all these are the best example of step growth polymerization. And next question is, define the term monomer. So small molecules which combine with each other to form polymer. So simply we say monomer means, from the Greek mono means one or single. Mer means unit or part. So single part or single unit is called monomer. So here monomer is a low molecular weight compound. So this number of monomer units combine to form polymer. And next one is, what is the repeat unit of natural rubber? So already we know that natural rubber means it is obtained from trees like Hevea brasileus or rubber trees. So it containing main basic unit is isoprene. So this isoprene undergoes polymerization then form polyisoprene. So the repeated unit of natural rubber is isoprene. Next question is, name the catalyst used in preparation of PVC. So here the catalyst used in preparation of PVC is polyvinyl chloride preparation. In that case we are using catalyst is benzoyl peroxide. Benzoyl peroxide or hydrogen peroxide also we are using. So here the main catalyst which are used for the preparation of PVC is benzoyl peroxide or hydrogen peroxide. And next question is, write the example of thermoplastic resins. So here example of thermoplastic resins are polyethylene and polyvinyl chloride. So already we know that what is the meaning of thermoplastics? Soft on heating, hard on cooling. This type of plastics are called thermoplastics. So here the best example of thermoplastics are polyethylene and polyvinyl chloride. And next question is, write the example of thermosetting resins. So example of thermosetting resins are bakelite and nylon 66. So already we know that what is the meaning of thermosetting resins? Hard on heating. Once it convert hard material, we cannot soft again. We cannot reuse this type of plastics. So the type of plastics are called thermosetting plastics, which is formed by the condensation polymerization. So the best example of thermosetting resins are bakelite and nylon 66. And next question is, name the catalyst used in preparation of a bakelite. So the catalyst used in the preparation of bakelite is hexamethylene tetramine. So what is the catalyst we are using here in this preparation of bakelite? Hexamethylene tetramine. Formula is CH2,6-hexamethylene. So 6 methylene groups. Tetramine N4. CH2,6N4. So hexamethylene tetramine is used as a catalyst in the preparation of bakelite. And next question is, name 2 natural polymers which are used as a textile polymers. So here, what are the natural polymers? Name 2 natural polymers which are used in textile polymers. So we are using the natural polymers are silk, wool, cotton, jute, etc. These all are the natural polymers which are used in this textile industry. So such as silk, wool, jute, cotton, etc. These are obtained from plants and animals. So these are the best example of natural polymers. These are used in this textile industry. And next question is, write the monomers used in nylon 66. So what are the monomers used in this preparation of nylon 66? So the monomers used in nylon 66 is hexamethylene diamine and adipic acid. So what is the chemical structure of hexamethylene diamine? So 6 methylene groups, hexamethylene diamine, 2 NH2 groups. So hexamethylene diamine plus adipic acid. So CH2,4 and acid function group COOH. Here also C double bond OH. So this is adipic acid. So these 2 monomers are used in this the preparation of nylon 66. So nylon 66 is prepared by the what are the monomers we are using here? Hexamethylene diamine and adipic acid, which undergoes condensation polymerization, then form nylon 66. These are the structures of hexamethylene diamine and adipic acid, which is used for the preparation of nylon 66 by the which type of polymerization? Condensation polymerization. And next question is, what is biodegradable polymers? So biodegradable polymers, bio, that means easily degrade by the reaction of enzymatic reactions or algae or fungi, etc. So these polymers are which undergo degradation by the naturally occurring microorganisms like algae, fungi and bacteria. So these polymers easily undergoes degradation by the reaction of enzymatic reactions or microorganisms like algae, fungi and bacteria. So this type of polymers are called biodegradable polymers, and the best example is polylactic acid or polyvinyl alcohol. These are the best example of biodegradable polymers. So these polymers easily undergoes degradation by enzymatic reactions or microorganisms like algae or fungi or bacteria. And next question is, what are elastomers? So rubbers, also known as elastomers. So these are high polymers which have elastic properties in excess. So simply we says elastomer means rubber-like nature. Rubber-like properties are called elastomer. So which are being stretched at least 150% of their original length without breaking. And it retains same original shape when we release the stress is called elastomer. Rubber-like elasticity is called elastomer. So the most important property of elastomers are elasticity nature. So those polymers which are capable of being stretched at least 150% of their original length without breaking. And it is same original shape when we release the stress is known as elastomers. So the best example of elastomers are bunias and butyl rubber. Bunias and butyl rubber. And next question is define natural rubber. So it is a high molecular weight hydrocarbon polymer represented by the formula is C5H8X. So it is obtained from milk emulsion is called latex by the tapping the bark of the tree like Hevia brasilius. It is the polymer of isoprene units. So simply we says natural rubber, it is obtained from trees as a Hevia brasilius rubber trees. So when we cut the rubber tree, produce milky white fluid. So that is named as latex. So it containing basic unit is isoprene. So this isoprene undergoes polymerization then form polyisoprene. And next question is name two synthetic polymers which are used as textile fibers. So what are the synthetic fibers, synthetic polymers used in this textile industry or textile fibers? Nylon 66 and terling. So this nylon 66 and terling are the synthetic polymers that are used in this textile fibers or textile industry. And next question is what is vulcanization? So it is defined as heating the raw rubber at 100 to 140 degrees centigrade in the process of sulfur. That means natural rubber heated with sulfur at 100 to 140 degrees centigrade. So here sulfur combined with double bonds of the rubber spring. So this process is called vulcanization. So what purpose we are using this vulcanization? Because improve the properties of raw rubber. Improve the properties like elasticity, durability, water absorption capacity. So many improve the properties of rubber. So that purpose we are using this process vulcanization. So this natural rubber, raw rubber heated with sulfur at 100 to 140 degrees centigrade. So in this case, sulfur combines with double bonds of the rubber spring. This is called vulcanization. So clear reactions already I explained previous classes when we discussed about the vulcanization of raw rubber. So here just definition of vulcanization is raw rubber is heated with sulfur at 100 to 140 degrees centigrade. So this process is called vulcanization. It is used for the improve the properties of natural rubber or raw rubber. Name the catalyst used in bunias rubber. So what is the catalyst you are using the preparation of bunias? Here sodium. Sodium acts as a catalyst. Bunias. Bu stands for butadiene. S stands for styrene. These are the monomer used for the preparation of bunias polymer. So here Na stands for sodium. Here sodium acts as a catalyst. And next question is mention the chemicals used in the preparation of thiol rubber. So what are the chemicals used in the preparation of thiol rubber? So the chemicals used in preparation of thiol rubber is sodium polysulfide, and ethylene dichloride. Sodium polysulfide and ethylene dichloride undergoes polymerization then form thiol rubber. Next question is what is meant by degree of polymerization? So the number of repeating units in a chain of a polymer. So number, if in case for example in a polyethylene degree of polymerization is 100. So what is the meaning 100 means 100 monomeric ethylene monomeric units repeated several times. So the number of repeating units in a polymer chain is called the degree of polymerization. And next question is, what are homochain polymers? What are homochain polymers? So a polymer which consists of same species of atoms. Example, carbons in polymer chain. So that is called homochain polymer. Otherwise, same monomer units repeated several times, that is also called homochain polymers. For example, polyvinyl chloride. So vinyl chloride monomer repeated several times. So that is also called homopolymer or homochain polymer. So generally this type of polymer is formed by addition polymerization. And next question is, what are heterochain polymers? So here a polymer which consists of different species of atoms. Example, carbon and silica in a polymer chain. So next question is, name the catalyst used in the preparation of polylactic acid. So already we know that polylactic acid is the best example of biodegradable polymer. So what is the catalyst used for the preparation of polylactic acid? Stannous octate. So stannous octate used as a catalyst in the preparation of polylactic acid. And next question is, what are the sources of biodegradable polymers? So these biodegradable polymers may be made from biosources. So what are the biosources? Like corn, wood, cellulose, etc. So synthesized from small molecules like lactic acid and vinyl acetate. So naturally occurring polymers is called biodegradable polymers, and these polymers easily undergoes degradation also by enzymatic reactions or microorganisms like algae, fungi, etc. And next question is, what is the composition of natural rubber? So the composition of natural rubber is polyisoprene. So already we know that when we cut the rubber tree, it produces milky white fluid that is called latex. So it containing basic unit is isoprene. So this isoprene undergoes polymerization and form polyisoprene. So the composition of natural rubber is polyisoprene. And next question is, write the example of biodegradable polymers. So the biodegradable polymers are polylactic acid and polyvinyl acetate. So already we know that these biodegradable polymers means these polymers easily undergoes degradation by enzymatic reactions or microorganisms, not harmful for environment. The best example of biodegradable polymers are polylactic acid and polyvinyl alcohol or polyvinyl acetate. And next question is, what is synthetic rubber? So synthetic rubber can be produced artificially via the polymerization of monomers into polymers. To be prepared in the laboratories, generally synthetic rubbers. Best example of synthetic rubbers are butyl rubber and thiol rubber. So they are prepared artificially, that means externally, so via the polymerization of monomers into polymers. And next question is, what elements is in vulcanized rubber? So already we know that vulcanization purpose we are using sulfur. So natural rubber heated with sulfur at 100 to 140 degrees centigrade. So in this case, sulfur combines with double bonds of the rubber spring. So this process is called vulcanization. So sulfur is the most commonly used element in vulcanization process of rubber. So here this process is mainly used for the improve the properties of natural rubber. And next question is, what is the temperature of vulcanization of natural rubber? So just now we discussed already. So when the natural rubber is treated with sulfur or heating with sulfur at 100 to 140 degrees centigrade temperature. So in this case, what are the reactions takes place? Sulfur combines double bonds of the isoprene molecule or rubber springs. So then form vulcanized rubber. It improves the properties of natural rubber or raw rubber. So what is the temperature range here we are maintaining in this vulcanization process? 100 to 140 degree centigrade. And next question is, why sulfur is used in vulcanization of natural rubber? So vulcanization of rubber involves heating in the presence of sulfur at 100 to 140 degrees centigrade. So the results in cross-linking of the chains of rubber and sulfur to form a stable polymer which is more strong and stable. So during this process, vulcanization, when heating with sulfur at 100 to 140 degrees centigrade, sulfur combines with double bonds of the rubber spring. So in that case, what is the resulting polymer is cross-linking of the chains of rubber and sulfur to forms a stable polymer, which is more strong and stable polymer is formed during this vulcanization process. So next question is, what is a non-biodegradable polymer? So biodegradable polymers means easily undergoes degradation by enzymatic reactions or microorganisms. But here non-biodegradable polymers means it consists of long chains of carbon and hydrogen atoms. So these non-biodegradable polymers consist of long chains of carbon and hydrogen atoms. So these molecules form an interatomic type of bonding. These are form interatomic type of bonding, and it is tough for microbes to break the bonds and digest them. And these polymers do not undergo degradation easily. So that is the main difference between biodegradable polymers and non-biodegradable polymers. Here the best example, all the synthetic polymers are non-biodegradable polymers. So in this session we'll learn about definition terminology of polymer technology. So I hope understood all. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.